Hey Malmo, happy to be here today. Unfortunately, this session is again after lunch. Hopefully that won't affect your attention. So many full-stack web developers nowadays need to use two languages to do their job. And in this session, I'll show you how you can use just a single language, which, as the title of the session suggests, is F#, to do full-stack web development. My name is Tomasz Heimowski. I come from Poland, and I work remotely as a software contractor, primarily with F#. And I also do open source contributions around F#, mainly around the areas that we'll be exploring today. If you want to trace my activity, I go by the Heimowski nickname on Twitter and GitHub, and I have the heimowski.com website. So I said full stack web, but I didn't explain what I mean by that. So for the sake of this session, let's assume that it means that the developer is responsible for creating or maintaining a web application on both server and client side, or if you prefer, on back and front ends. One might argue that this is not sufficient to call someone full stack, but let's not go into those kind of debates. And you might be asking whether it actually makes any difference to whether you use one or two languages for full stack web development. And when the project is quite big and it's split into server and client side and are two separate teams responsible for maintaining that, it probably doesn't make that much difference. But imagine that you want to create a prototype or a proof of concept application and your team is not very big, or you're just a single developer that needs to create the application. Then learning two languages might be a barrier for you, and using those might be cumbersome. And F# wasn't the first one to solve this issue. Back in the days, Node.js was the answer for JavaScript developers that wanted to go from client side to the server side, and Node.js allowed them to write server applications. One aspect that came out with the fact was that they could reuse some certain parts of code to target both server and client. And they even came up with a name for that, which was mentioned at today's keynote, which is isomorphic. And that sounds really cool, right, if you create isomorphic apps. So as I said, F# wasn't the first one to solve this issue. There are other languages as well. For example, C# and the latest bits of Blazor, which I'll come back at the end of this session. So anyway, I want to show you how you can do that in F# because I specialize in that language, and I think it's really cool. And the fact that you can do full stack web development with F# is pretty exciting. The session will be a bit of live coding, so we'll create an application based on a to-do MVC project. And to-do MVC is a project that aims to compare different technologies on the front-end side. And it comes with a specific set of requirements for a to-do list application. So I can create new to-dos, mark them as complete, or delete, etc. So there's a specific set of requirements, and there are different technologies that show you how you can write the same application. So for example, you get React, Angular, Vue.js, or Knockout.js, as well as a couple of compiled to JavaScript solutions such as Elm or TypeScript. So the idea here is that tech leaders can choose a technology that fits their needs, comparing source code that implements the same application. So that's for the front-end side, and there's also a corresponding project for the backend, which was inspired by the to-do MVC. This one is called To The Backend, and this one even comes with an automated test suite that you can fire against your HTTP server to test whether you're meeting the requirements. And as you can see, there are different languages, frameworks, and technologies. Each of those are implementing the same application, and you can compare the source code and what it looks like. So today, we're going to combine those two projects and implement the application both on the server and client side. And we'll implement subset of the to-do MVC requirements using F# on server and client side. And F#, who has ever used F#? Okay, a couple of people. So unfortunately, I will not have enough time to go into semantics or syntax details of F#. But hopefully that won't affect the big picture or the goal of this session, which I want to be to encourage you to try out F# and this development of full stack web applications using F#. But let me just briefly describe about the language, what it is. So it was born as a Microsoft research project, but it's really open source by nature. So you might recall the moment when Microsoft pushed to GitHub a lot of projects. F# was open source even much before that happened. So many different contributions come from community. A lot of features do not come directly from Microsoft. And it's a general purpose language, which I want to emphasize because some might claim that it's only meant for specific areas or domains, which I don't think is the case. And today I'm going to show you that you can create standard line of business applications using F#. It's functional first, which means that we suggest to use a programming paradigm called functional. But if necessary, you can fall back to object orientation or procedural programming when necessary, because F# is fully interoperable with .NET. So it runs on .NET Mono, .NET Core, as well as we'll see today in your web browser. And the application that we'll build will use for that purpose something called Safe Stack. And this is a stack combining a couple of technologies. If you're new to F#, you might just recognize Azure from this list. But don't worry, I'll try to go through the remaining ones and show them in practice. In a big picture, Safe Stack combines those several open source projects, and you write F# everywhere. So on server side, on client side, scripts, etc. The acronym fits nicely into type safety nature of the language, especially on the client side, because JavaScript always used to be and probably will be dynamically typed. So you might get into stupid kind of bugs and issues in the runtime. So the powerful type system that F# has comes now to the client side, which is pretty huge. Right, so there are a couple of prerequisites that you need for writing full stack web applications and F# in F#. First, you need to install .NET SDK 2.2. Currently, we're in progress of migrating to 3.0. There's a global .NET tool called Fake, which is necessary for building and running the application. And then, even though we write the client side in F#, we still need a Node and a package manager, YAR or NPM for the client stuff. If you're not comfortable installing those prerequisites on your local box, there's an alternative. You can use Visual Studio Code and an awesome extension called Remote Containers. And that basically takes the prerequisites in an isolated container, which you interact with via your Visual Studio Code editor. To create a project from scratch, you use the .NET SDK CLI and .NET New command. First, to install the template, then to create a project from that template, and finally, you use the Fake utility to build and run your application. So now let's dive deep into the Safe Stack and decode the letter by letter the acronym. And first letter S stands for Saturn. So that's the server side. This is a web server written in F#, and you can really think of it as a thin layer on top of ASP.NET Core. So you get all the benefits from that framework, performance, extensibility, etc. Let me show you how it looks like in practice to create the application on server side in F#. So this is my Visual Studio Code. I have my server.fs source file, which is F# code. And as you can see in my terminal, I'm running the fake script already. So let's hide that. And by the way, this is not bare bones project created from the template. I added a couple of features to have a good starting point. So skipping aside some of the details, let's see what's this guy over here. We call it a web app, and basically it's like a set of rules or routes for your HTTP server. Currently, we have just a single one, which says that for get HTTP request to URL/API/init, we should invoke this handler. And inside this handler, we basically create an object with value of 42 and return that as JSON. If I fire the GET request against this URL, I get in response 200 OK with the JSON payload and value of 42. Now what I want to do is implement two new endpoints, get and post to /API/todos. The first one will fetch the list of the to-dos as JSON, and the second post will be the other way around. So it will take the list of JSON of to-dos as in its body, and basically will save that in the server. So let's start with the get one. Let me close this one. And for the get API to-dos, I need to create the to-do type. So let's start with that. Type to-do will be F# record type, ID of type GUID, then description of type string, and finally is completed. That will be a flag of type bool. And now let me just import two functions for loading and saving the to-dos from Azure. So what they're doing here, they're pretty simple. Basically, we use Azure storage and a container, and we store a single JSON file with the to-do list. So load function will get that raw string from a blob container, and then we'll try to deserialize that to a to-do list and return that. And save function, on the other hand, takes to-dos as a parameter, serialize that to a raw string, and tries to save that to Azure blob storage. So having those two functions in place, I can proceed with implementing my endpoints. So I'll copy this guy, and API to-dos will have a handler where I'm gonna load the to-dos from the Azure, and then I'm gonna just return them as JSON. So when I save my file, the fake script is running the ASP.NET Core application in watch mode, so the application is being recompiled and rerun automatically for me. And now I can fire the GET request against API to-dos. And as you can see, in response, I get 200 OK and a list of 5 to-dos that I have currently in my Azure storage. So now let's implement the post one. And that will be pretty similar to this one. Just copy and change get to post. And here, instead of loading that from Azure, I'll load that from our context. So I'll use this method that I'll describe in a second. And then I'm going to call save on those to-dos. And instead of returning them, I just return a simple string saved. So what's happening here is that I'm using bind model async method of ASP.NET Core HTTP context, which basically takes a look at the HTTP request body and tries to deserialize that to our type parameter over here, which is to-do list in this case. And when I have the to-dos in place, I can invoke my save function to Azure. So now after that recompiled, I can fire the post request. As you can see, again, 200 OK, saved. So by the way, this list that I just posted contains 4 to-dos, which correspond to the 4 letters of save stack, which we're going to see today. And now if I click get API to-dos, instead of 5 to-dos as I had previously, I get now 4. So it proves that this post worked. Right, so that was S for Saturn, basically F# on the server side. Saturn is the web server on top of ASP.NET Core. Then next letter in SAFE acronym is A for Azure, which is obviously the cloud provider from Microsoft. It's not in any specific way related to F# here, just the fact that it's easy to integrate SAFE apps with Azure. That's why it's there, as well as the template. It comes with an option that allows you to easily deploy SAFE application to Azure App Engine. But otherwise, not really tied to F# in a specific way. Just keep in mind, Azure is not the only option. There are other integrations created by community. For example, you can create a Docker image or deploy to Google Cloud, thanks to community contributions. Moving forward, third letter, F, stands for Fable, which is the thing that allows us to target F# for browsers or JavaScript. So F stands for Fable. which is an F# to JavaScript compiler. And let me show you how it looks like in practice. So first, I'll just move side by side my application and my editor. So now on the right-hand side, this is the application that I'm running. And on the left-hand side, I have my editor. And now I'll move to client.fs source file, which is, again, F#. But this time, it's not being compiled to ASP.NET Core, but to JavaScript. So all this client.fs file, this F# code is compiled to JavaScript. I scroll to the very bottom, where, as you can see, I have a function called run, which takes as a parameter a to-do list, and basically bootstraps the program. Currently, I'm running that function with an empty list, and that's why we can't see any to-dos in the UI. What I want to do now is to load those to-dos from the server and then display them in the application. And for that purpose, let me create a function called load and run. And that function will use a promise computation expression. Promise is basically the abstraction in JavaScript word for asynchronous operations. And here I'm going to use fetch API. And fetch API is basically the way in JavaScript that you do the HTTP requests. And fetch as to-do list resource from /API/todos. And then I'm going to call run on those to-dos. So having that in place, I can invoke this function and pass it to promise.start to start this promise. And when I save this file, the fake script is also running the client in a watch mode. So it's recompiling the sources to JavaScript and rerunning the applications, rerunning the application under the hood. So as you can see, in the browser, it's refreshed and now displays the list of 4 to-dos that we have in the Azure storage. And the first one is completed, and the rest of those to-dos are not completed. And in my client application, I can now list the to-dos as well as type something here and click enter. That will append to the list. But this change is only client side because when I refresh the browser, it's gone. So when I refresh the browser, it fetched the list of 4 to-dos from the server. So to fix that, I need to now to implement the saving to server. And for that purpose, I'll create save function taking to-dos as a parameter. And here again, we're going to use the promise computation expression and fetch API. But this time, it will be the post function. And we'll pass in to-do list as a parameter and expect the string as a return value. And again, URL will be API/todos, and the body will be todos itself. We don't anything here, so we'll just return an F# unit. And now I can invoke my save function here whenever my model changes. And I'll come to model in a few minutes. And just invoke promise.start. Okay, save the sources. The application should now recompile. And when I add a new to-do, we should hopefully persist that change in the storage. As you can see, it's there. So F for Fable, a project that allows us to compile F# to JavaScript. And actually, we can run more targets than just browser. It can also output code that will be understood by the Node.js runtime. So basically, whenever you can run a JavaScript, you can take F# and compile that with Fable to JavaScript. So to maintain your code in F#, that's really huge. And last but not least, E stands for Elmish, which is a library on top of Fable that allows to create rich client applications. And it follows a pattern called Model View Update, or MVU in short. And the name itself comes from a programming language called Elm. So this Elmish library is really inspired by this language, where this architecture comes from also. The Elm language is basically a programming language for frontend. Let me show you the Model View Update pattern now in practice, because it's pretty easy. There are basically just a couple of building blocks that make this pattern. So first building block is a model. And model is basically everything that we have on our application on the client side, the whole state. So currently, there's this to-do list, as well as we keep track of input value in this text input. We need some initial model, so when we fetch the to-dos from the server, we assign that value, that to-dos value to that list, and we set the input to an empty string initially. That's why I can see the placeholder here. Next building block of MVU pattern is called a message, and you can think of messages as anything that can happen within your application. And currently, it's just update input or add. So every keystroke that I do in this text input triggers the update input message, and when I click enter, it triggers the add message. So I need some way of handling those messages, and that's where the update function comes in. Update function is the U for MVU, and here what it does is basically it takes next message, current model, and computes next model, so like next stage in our application. If the message is update input, we basically just amend this input value. But on the other hand, if it's add, we need to create an instance of a new to-do and append that new to-do to our to-dos list, as well as make the input empty. To create the new to-do, we need to fill all of the fields. That's the requirement for F# records. And for description, we take the value of model input. The is completed will be set to false by default and generate the ID by GUID.newGUID method. So that's the update function. And then I have a helper function over here on enter, which detects whether a key press was enter. And finally, last building block of MVU pattern is view. So the V letter for MVU pattern. And here we're actually using React.js under the hood because of its declarative nature. It fits really nicely into this stack. And the view part here consists of a couple of functions which all have the same shape. So they, as the first parameter, they will take some kind of model. So either the text input or the to-do list or a single to-do, and a dispatch function. Dispatch function is something that the Elmish library gives us, and it allows to trigger the messages from within the user interface. So view input function is responsible for rendering this text input over here. As you can see, there's this React element called input, CSS class, placeholder that's displayed whenever the input is empty, binding to our value, and then we can trigger the add message on enter key, or whenever the text changes, we just trigger the update input message. And we trigger that by passing that to the dispatch function. So that's the view input. Then view to-do function takes a single to-do, and basically is responsible for rendering a single to-do. So there's a label with the description and a conditional class called completed based on whether a to-do is completed or not. So this strike through over here that you can see is because the to-do is completed. Then view to-dos basically aggregates all to-dos into a list and is responsible for rendering this whole list of to-dos. And finally, view function is like gluing up the view input and view to-dos, so really like a root entry to our view part. And having those three functions in place, init, update, and view, we can create an Elmish application and run it. So now let's see how it works in practice by adding a new feature. And the feature will be deleting a to-do from this list. And personally, I like to start with the user interface. So let's add a button just after this label over here. So we'll add a button. And the button will have a CSS class called destroy. Recall that whenever I change the source file over here, the changes are applied immediately. So now when I move my mouse over a to-do, there's a red cross over here in the right corner on the right-hand side that appears that I still need to handle the on-click event because nothing happens currently. So let's assign a handler for the on-click event. And here I'm going to call destroy message with current to-do ID and pass it to the dispatch function. So destroy message is something that I still need to create, and I'll pass to-do ID along with this message and pass it to the dispatch function. So let's create the destroy function, destroy message, sorry, and it will carry the GUID to-do ID when I added this new case to my type, as you can see, F# compiler now warns me about uncovered case for our message. So there's a new case, destroy, which has not been covered yet in our pattern matching expression, which could result in a runtime error. So F# is nice enough to tell me about that, which is pretty cool. Let's fix this issue by importing a snippet. Basically, what the snippet does is it filters the list of to-dos based on whether the ID matches the one from the message. So now when I click the button, the to-do is gone, and the changes are persisted. So to rehearse, let's add one more feature, which will be marking or toggling the completed flag on a to-do. And let's start with the user interface again, and we'll add an input just before the label this time. And by default, the type of input will be text, but we really want a checkbox type. So let's change the type to checkbox. So now we can see this is a square that we can check. But it doesn't look nice, but fortunately we have the CSS definitions with a class called toggle, which makes it look much nicer. So it's hardly visible on this projector, but when it's checked, it looks like this one, green. And when it's not checked, it's a gray circle. So whether a checkbox is checked or not, we control that by checked property, which takes a Boolean as a parameter. So when I hardcode that to true, as you can see, all the to-dos are now marked, but this is not what I wanted. I really want to bind it to whether the to-do itself is completed or not. So because that's a Boolean flag, I can just pass it directly. So now, as you can see, only the first one is checked. And to handle events, I need to assign to onChange event. And here I'm going to call toggle message, also with the to-do ID, and pass it to dispatch function. So same story here. I will need to create the toggle message that will handle the logic for me. So let's add toggle of GUID. And again, F# compiler warns me about uncovered case for toggle. So let's fix that by importing a snippet. And the snippet, basically what it does, it's mapping every to-do with the toggle function. And the toggle function, when the ID matches, basically sets the isCompleted flag to not isCompleted. So now when I mark the checkbox, as you can see, the changes are reflected with the strike through and also persisted in data store. So when I refresh the page, it's still there. OK, so this was for the E4 Elmish library on top of Fable, which allows to create rich client applications on the browser side. It follows a model view update pattern or MVU. And to conclude, SAFE consists of 4 different components: S for Saturn, web server in F# on top of ASP.NET Core, A for Azure, F for Fable, the F# to JavaScript compiler, and E for Elmish, library on top of Fable, which allows to create those rich client applications. What are the practical benefits of using SAFE? So as I mentioned at the beginning, you just need a single language to write the web application full stack from backend to client side. And you might argue that you need to learn F# if you don't know it. But trust me, after you learn F#, it's really easy to use. And also, if you don't plan to use F# afterwards, I really encourage you to try F# out, because if you're, for example, an object-oriented programmer using C#, Java, or whatever, it's really worth to learn a functional programming language, because that will make you a better programmer in object-oriented world as well. So it's really worth it. The SAFE template comes with a couple of options, for example, the deployment options that make it easy to deploy to your cloud provider, favorite cloud provider. And as you saw, the development experience is really nice and smooth. So I didn't need to switch between windows to recompile or rerun the application. Everything is done for me automatically. So that's really nice. And Fable integrates with existing huge JavaScript ecosystem. We don't try to reinvent the wheel, but rather just use the tools that are out there, and there are really a lot of tools that JavaScript has in its ecosystem. What's more into safe stack? So for example, because the code on server and client side is in F#, we can extract and put some of the parts in a shared module. Let me show you how it looks like. So you might have spotted that the to-do type in client and server look exactly the same. So what I can do is to grab the type from server and move it to shared module, save the changes, wait for the application on server side to refresh. And after that's ready, I can remove the type from client.fs and use the type from shared module. So I have single type that's recompiled now to both server side and client side. And the application is still running as it was before. Next thing I could do is, for example, to grab the string API to-dos and extract that to a constant value in shared module so that I can reuse that in both client and server sides. Everything you can think of, models, protocols, messages, validation logic that can be extracted, you can put into shared module and compile that to both server and client side, which is pretty huge. And thanks to the fact that we integrate with existing tools, we can use, for example, a thing called Remote DevTools Debugger, which is kind of like a time travel machine, sorry. And every message is recorded as a step in this history, and you can rewind the history from the beginning to trace what's going on in your application, which is nice for troubleshooting or debugging. You can even export that history to a file and send to a colleague to reproduce a bug. We have some nice features on top of full stack, on top of safe, such as full stack debugging in Visual Studio Code, which means that using a certain configuration in Visual Studio Code, you can enter a debugging session where you can set breakpoints in both server and client side and hit those breakpoints in the same session. And then using React, you can render the views also. When using Node.js, you can render the views on the server side for better search engine optimization, for example. And that's also possible in SafeStack, but this time not using Node.js, but instead we'll be using ASP.NET Core, which does the same thing, but it does it much faster than Node.js alternative. So really nice thing here as well. Right, so if you're a C# developer, you might ask, why would I care if now there's this Blazor project and I can be full stack web developer using C# and Blazor? And while the Blazor project is certainly very exciting, there are some aspects that you need to take into consideration before jumping straight into this technology. And I haven't done I have no experience with Blazor whatsoever, so that's a disclaimer. But I did some basic research so that I can outline the main differences between Fable and Blazor. So obviously, the first difference is the language itself. So for Blazor, that's C#, but that's not really strictly C#. It's rather the Razor extension, which I believe is for the engine view, for the view engine. So it's not exactly the same C# that you would write for your .NET application. On the other hand, the F# code in Fable is exactly the same on the client side as you would do that for .NET. But the main difference really between Fable and Blazor is the runtime itself. So the output of Fable compilation is a JavaScript bundle, which interacts with JavaScript directly. On the other hand, Blazor works completely differently. It's much more complicated. So Mono is basically compiled to WebAssembly, and you get a .NET runtime within WebAssembly that you can run your Blazor applications in. And that means you need to take into consideration all facts related to WebAssembly. There are obviously advantages of WebAssembly, but WebAssembly is still an early technology, so there might be some breaking changes. And there's also a fact that you need to remember that WebAssembly is not there to replace JavaScript completely. In fact, to run a WebAssembly module, you need to trigger that from JavaScript, as far as I know. So there will be still some compatibility with JavaScript existing. And regarding interop with JavaScript, because Fable outputs JavaScript directly, you do that, you call the NPM packages or browser APIs through a thing called bindings, Fable bindings, which is basically F# types and functions on top of JavaScript libraries. And for the most popular libraries, there are already F# Fable bindings that you can find and use as a NuGet package. If there are none, you can use TS2Fable project, which compiles TypeScript definitions to Fable bindings. It might not always work because sometimes in TypeScript do not map one-to-one to F#. If that's the case, you're left with implementing the bindings yourself, but that's not also hard, and you can just create the bindings for the functions that you need. So one more important aspect is about Blazor is that it's split into server and WebAssembly part. And while server part, I believe, is already in stable version, the WebAssembly part is still in preview even for ASP.NET Core 3.1. So just please keep in mind those differences. And to conclude, a couple of resources. Documentation for SafeStack. If you want to find out more about SafeStack, go check out the docs. I have a bit more hardcore demo live coding session from last year, F# Exchange Edition. GitHub SafeStack organization. The slides are publicly available, and I'll tweet a link to the slides after the session. Source code is on GitHub. Yeah, so that's pretty much it. Thank you for listening. Yeah, and I think we have some time for questions, if there are any. Otherwise, you can grab me after the session or during the conference. I'll be hanging around till Friday. So thank you once again, and see you around. Cheers.